Hi there, welcome to iTWireTV. Today we're joined again by Craig Dore, Field CTO for RSA Identity Solutions, Australia, New Zealand and Asia South. Welcome back, Craig. Thank you again for joining us.
Hello, Mr. David.
Excellent. So we've been talking about AI is giving us an identity crisis. So this is part 2 of 3. So last time we spoke about zero trust and how it's not, there is a myth around it and it's not necessarily the solution that we all think it is. Today, we're talking about how the risks around AI as well. So lots of risks, but fortunately, next time we're going to talk about a solution, aren't we, Craig? So that's great.
Yeah, the risks. Those are the things that keep people like me up at night.
Yeah.
I think, I mean, obviously there's a lot of excitement around AI, and the subset of AI referred to as a large language model, or LLM. And we've seen, I think it's around 4,000 new organizations that have come out of the woodwork since ChatGPT as a technology was released in late November of last year. Yeah, and I myself, I mean, I've used it in a whole manner of different interesting ways, like having it recommend recipes with their ingredients to me, and then the capability exists where you can use a ChatGPT plugin to automate ordering the ingredients for the recipe to your local grocery store. So you can see that it has a lot of benefits and a lot of utility that cuts across everything from academia and learning to home automation and so on. But, with every new technology comes the other side of the sword, which is the risks, right? And that's kind of what I wanted to kind of focus on today, was around what risks from a cybersecurity perspective. And I'm sure that there's a ream of them. But if you think of that capability of its own ability, it was trained on source code and programming languages. And its ability to generate source code is actually one of its best characteristics, to the point where it's actually the capability has arisen for it to not only write its own code, but have the code that it writes write its own code. And that's referred to as polymorphism. And so polymorphic malware is kind of the bane of any cybersecurity practitioner's existence, right? And so that's a real life example. Another example of it being used or exploited out in the wild is ChatGPT. When they released, the initial cuts of the technology, they finally realized that it was being used in ways that might be racially inflammatory or discriminatory. Non-inclusive language is being encouraged in those ways. And one of the things that the organizers behind it, OpenAI, did was put up guardrails around it. So when you use the latest iteration of the technology, you're in a ringed fence. It's very hard for you to use it, or at least manipulate it, to generate unwanted content, if you will, that sounds authoritative. What hackers have done is they've used the API, or the programming side of things, to interact with ChatGPT and get around all of the sort of the gatekeeping technology that's up there. And what that means is these hackers are literally selling unfettered access to ChatGPT in order for you to perpetrate nefarious deeds, right? So they're literally erecting a subscriber service around unfettered access into ChatGPT for you to do things like, find out how to build a bomb and things like that.
Wow, so we're seeing all those things in the wild, and it sounds like it's just so easy to do. So does that mean we're going to see an increase in these sorts of threats in practice, in reality?
Yeah, absolutely. I mean, if you think of the skill levels involved with perpetrating a hack, the skill levels were up here to write code. Now you can use ChatGPT to automate a lot of that. Second is the ease of use of generating fake misinformation or fake content to fool people for whatever purpose, right? And so in this kind of I guess you'd say from a cybersecurity practitioner standpoint, or an organization that's trying to monitor what's going on in terms of, inbound threats and so on. There's a, team of girls and boys that run what's termed as a security operations center, or a SOC. It also has incident response center, which is a CERC. And so these people, their full-time job is literally being the watchers on the network, looking for using tools and technologies to monitor the network, monitor all inbound and outbound, watch the packets flowing across the network, watching what users are doing, and making sure that one, they're not opening the organization up to risk, or doing, bad things on the network that are, say, against policy, but also what's coming in, like are there, aberrant malware or advanced persistent threats beaconing back home across your network. And so from a scale perspective, these people, even now, pre-AI, pre this deluge of intrusions, they're already overwhelmed. There was a study done across last year where it was determined that it took an average of 277 days across a year to react or detect a breach that was in progress. That's a long time. So just to put that into perspective, if you got breached on January 1st, the SOC wouldn't get to you until like late October, right? So that's a lot of time for people to do bad things, right? And actually, I read another interesting stat yesterday that said, from a certain set of breach surveys, 58% of those that had been breached, the only reason they knew that they were breached in the first place is because the attackers told them.
Oh, wow.
So they're, and I'm not casting aspersions here. I mean, these are hard problems, right? Cybersecurity is hard, right? And everyone has, are time constrained and are resource constrained and skills restrained. So what's going to burst the dam, right? And so the notion of not using AI when the attackers are using AI, well, it's a bit of a brain dead question. Of course, you're going to need to employ AI for you to monitor what is going on in terms of the volume and the scale of all the interactions and what's flowing, right?
Yeah. Yeah, amazing. Because, yeah, that does seem like a huge problem. So you can use AI to help counteract that.
Yeah, absolutely. And how would you do that? It would be like, so RSA, I work at RSA, but we've had a AI based capability for that type of monitoring for a long time, based on a subset of AI called machine learning. But from the raw capability across the industry, we need to see improvement there. And one of the aspects is around behavioral and context monitoring, right? AI can certainly get patterns of user and typical network behavior and create models around it, and then react when things deviate from that set model. And so from a scale perspective, having kind of a capability by which AI is really super duper learning what is typical normal behavior on your network is something that AI is really, really good at doing.
So how does that then relate back to identity and zero trust that we've been talking about?
Yeah, I think one aspect, as I touched on in the last session, was zero trust has a bit of an identity crisis because, again, it's a scale problem. The number of possible accesses is becoming very granular, and AI needs to be employed to do that. So when you back off a little bit, I mean, the hackers are perpetrating identity-related attacks against your organization. It's the weak link in the chain, and also the most consequential link in the chain when that does get breached. And so the notion is that how is AI going to help with that? Well, as stated, if most of the attacks are perpetrated against an identity, and we need to employ AI to protect identities in the applications that they can access. Obviously, using some behavioral and contextual awareness straight into the actual target application is really necessary. Because, like, if you look at an application, a typical app has a lot of moving parts to it. And sometimes, as I mentioned in our previous session, a typical user may only use, say, 20% of all the moving parts.
Yep.
If you had some means for you to peer into that application to see what those patterns were or what portion of the application was used, then obviously that's a task that can only be done by some level of automation and artificial intelligence. It can't be done by a human. And the identity equation relates back to the SOC watchers on the network. So the SOC team takes a really long time to respond. It's not their fault. It's just a question of volume. So who would own, from a perspective of monitoring and response, who can own an identity related threat? Are you going to, let's say, throw it up to the SOC when someone's account has been compromised? You can't wait 277 days for that to occur. It's kind of like if you're driving a car, where do you want the response time? Where do you want the reaction to take place? Do you want, if you're driving a car and you're about to hit a deer, do you want that to, go up to the mothership and back down and then hit the brakes? Or do you want the brakes to be smart enough to be able to react to the deer in front of the car in real time? And the answer is quite obvious. And so something, you can't throw it to the SOC, and you need basically the ability to sense it right at that moment, right? And the SOC can't own it. And so the idea is that providing a platform is absolutely critical for us to mitigate all of these risks that we're talking about today. The risk of the SOC being overwhelmed, the risk of an increase in cyber breaches related to identity. Where do we go from here? And I think we'll talk about that in the next session.
Excellent. No, well, thank you again, Craig. I look forward to hearing what the solution is and how we can bring all this together and deal with that volume of threat and scale. That's really sobering thoughts.
Yeah, that's the exciting part, is the solution, right? What can we do as an industry to really address the problem that we're seeing unfold in real time? So it's very exciting.
No, thank you. I look forward to talking to you again and hearing the solution.
All right, David. Thank you very much.
Take care. Bye-bye.
Cheers.